So what is a simultaneous equation? So for example, let's say we have the equation x minus y equal to 3 and 2x plus y equal to 0. So here, a simultaneous equation is essentially one that has two unknowns. So here you have x and y, and you have two equations. Now there are three methods to solving these equations. So what we're looking for is a value of x and a value of y that works for both of these equations. So the first method we'll look at is the method of elimination. Here we label each equation. So call this first one 1, the second equation 2. And what we want to do is either add 1 and 2 together or subtract a multiple of. So for example, we can times 2 on the second. So at least one of the variables is cancelled out. So either the y's cancel or the x's cancel. So here to cancel the x, for example, we can see that we need two lots of x's in the first one and just the one lot of x's in the second. So we can either do times 2 and subtract to cancel the x's, or we can cancel the y's. As the number in front of the y is the same, except that one is plus and the other one is a minus, we can just add these together to cancel the y's. So let's do that. So x plus 2x is equal to 3x, minus y plus y is 0, and 3 plus 0 is 3. Now we can divide both sides by 3 to give us x, because 3 divided by 3 is 1, equals to 3 divided by 3 is 1, so x equals 1. Now we have found one value of the two unknowns, so x equals 1. So what we can do is substitute this into any of the equations 1 or 2. So let's sub x equals 1 in 1. So we write down the equation first, x minus y equals 3. We substitute x equals 1, so wherever we see an x, we replace that with a 1. 1 minus y equals to 3. Now we have a minus y. Let's make this a positive, so add y on both sides. So here it becomes 1 minus y plus y is 0 equals 3 plus y. And then we want to get rid of the 3. So we do minus 3 on both sides. 1 take away 3 is minus 2 equals 3 take away 3 is 0, and y equals minus 2. So now we have found the values for both of these unknowns. Now, as a final check to ensure that we have the right answer, we can substitute these two values, x equals 1 and y equals minus 2, into the second equation, the equation we didn't use. So let's do that. So we're going to we can either substitute both of them at the same time and see that both sides equal. So for example, we can do x equals 1 and y equals minus 2 into 2. So 2x plus y equal to 0. Now x was 1, so 2 times x, so we have 2 times 1 plus a minus 2 equal to 0. So we simplify. So it becomes 2 minus 2 equals 0, and 0 equals 0, which is true. We can also just substitute y equal to minus 2 into 2, x minus y equal to 3. We substitute it in, so minus 2 equal to 3. So this becomes x plus 2 equal to 3, and then we minus 2 on both sides, and we're left with x equals 1, which is the same answer we had earlier. So this is the correct answer. So this was using the method of elimination. So now we'll look at how to solve this using another method called substitution. So the aim here is we take one of these equations and we rearrange the equation so we have either an x equals or a y equals. So let's take equation 1. So we're going to rearrange 1. So we have x minus y equal to 3. So now the easiest thing to rearrange here would be make it x equals. So x equals, so we need to do a plus y on both sides. So we have 3 plus y. And we'll call this 1 star. So we substitute 1 star in 2. So let's write the original equation, 2x plus y equal to 0. Now 2, we replace x with 3 plus y equal to 0. Then we expand the brackets, so we get 6 plus 2y plus y equal to 0. We simplify, so 6 plus 3y equal to 0. We minus 6 on both sides, 3y equal to minus 6. And then we simplify by divided by 3, and we get y equal to minus 2. Now this was the same answer we had previously. Now, the method is the same going forward in that we substitute our found value into one of the other equations. So we're going to sub y equals minus 2. We can take our pick between 1 and 2. We'll do in 1 in this case. So x minus y equal to 3. So we can do x minus 2 equal to 3. So we have x minus makes a plus, 2 equals 3. And we get rid of this by doing minus 2 on both sides. And then x equals 2 minus 2 is 0, 3 minus 2 is 1. Now this was the same answer we had previously using the elimination method, which is what you expect. Now as a check, you can substitute this x equals 1 into equation 2, and you should find that y equals minus 2. So the checks are the same as what we did in our previous example when we were looking at elimination. Now let's look at the third method. Now the third method is graphical. So what we need to do is draw both lines, equation 1 and equation 2, onto the grid. So you have your y-axis and the x-axis. So for 1, we'll draw a table chart of x and y's, and we'll just pick out 3 points. So we'll do minus 2, 0, and 2. So let's just plot this in, minus 2 and 2. So minus 2 plugged in, so we get y equals minus 5, 0 goes to minus 3, and 2 goes to minus 1. So let's plot these in. So if we say this is 5, 10, 5, 10. So now we plot these. So minus 2 goes to minus 5, 0 goes to a minus 3, and 2 goes to minus 1. Then we draw the lines in between, and then we repeat the same, but this time for the second equation, we'll use the same points we selected earlier, minus 2, 0, and 2. So now for x equals minus 2, y equals 4, 0 goes to 0, and 2 goes to minus 4. So let's plot these. Minus 2 goes to 4, 0 goes to 0, and 2 goes to minus 4. Now we draw a line joining these points. The point where these two lines cross is where your answer is. So here, this would be 1 and minus 2. So x equals 1 and y equals minus 2. Let's look at another example. So let's say we have the simultaneous equation 4x plus 2y equals to 10 and 3x plus 2y equals to 9. So again, we label each equation 1 and 2, and we'll start off with elimination. So looking at the equation, we can see that we have a 2y and a 2y. So they're the same. So the coefficient in front of the letter is the same. So it's the simplest one to eliminate. So we can subtract 2 from 1. So we're going to do 1 take away 2. Now we could also have done 2 take away 1. But if we did that, we would have 3x minus 4x. So we'll end up with minus x plus 2y minus 2y, which gives 0, equals 9 minus 10, which will be minus 1. So we end up with negatives. We're going to avoid that by doing 1 take away 2. So we'll rewrite this out again. That's 4x plus 2y equals to 10. 3x plus 2y equals to 9. And we're going to subtract both. So 4x minus 3x is x. 2y minus 2y is 0 equals 10 minus 9 is 1. So here we've actually already got to our answer. So x equals 1. So now we can sub x equal 1 into any of these equations. So let's say we'll put it into 2 this time. So we rewrite this out. So 3x plus 2y equals 9. And now wherever we see an x, we're going to replace it with 1. So 3 times 1 plus 2y equals to 9. So 3 times 1 is 3 plus 2y equals 9. Take away 3 on both sides. We're left with 6 and 2y. And y equals 3 because we can divide by 2 on both sides. So there's our second answer. Now that we know x equals 1 and y equals 3, we then do our check. So we can substitute this into any of the equations, but as we had done sub x equals 1 in 2, we'll try x equals 1 in 1 and see if we can get our y equals 3 again. 4x plus 2y equals to 10. 4 bracket 1, so we're replacing the x with 1 plus 2y equals to 10. 4 times 1 is 4. 2y equals 10. Then we get rid of the 4 by subtraction 4 on both sides. 2y equals 6. So y is equal to 3 because you can divide by 2 on both sides. And this is the same answer we had previously, so we're happy that this is correct. Now we'll look at the method of substitution. So given both equations have the smallest numbers 2 as a coefficient, we will then look at how we can divide these through by 2. So we're looking for an even number to keep the possibility of being able to simplify without ending up with a fraction. We're arranging 1. So we have 4x plus 2y equal to 10. So let's get rid of the 4x on both sides. So we're left with 2y equal to 10 minus 4x. And then we're going to divide by 2. Now we have to divide the whole thing by 2 on the right. So we simplify, so y equals, now 10 divided by 2 is 5, and minus 4 divided by 2 is minus 2. So now we've achieved what we wanted to do, in that we don't have a fraction involved, helps us in the next stage. Now we label this as 1 star, substitute 1 star in 2. So we'll write down equation 2 first, 3x plus 2y equal to 9. We substitute in, so 3x plus 2 bracket 5 minus 2x equal to 9. Expand, so 3x plus 2 times 5 is 10. 2 times 2, which is minus 4x, equals 9. So now we simplify, so 3x and that minus 4x becomes minus x. 10 stays as it is, equals 9. So now here, we can add x to both sides. So we end up with 9 plus x and 10. And then we get rid of the 9, so minus 9 and minus 9. We have x equals 1. Now this was the same answer we had previously. And the remaining part of this method is to substitute this x equals 1 back into equations 1 or 2 to get the value of y, which was the same as what we did in the previous method. Now graphical, we won't do again here, but it's simply draw the two graphs, rearrange both of these equations as y equals, plot the graph, see where they intersect, and that's the answer. So here you expect it to intersect at x equals 1 and y equals 3. Let's look at another example. In the next example, we will just be using elimination method and not substitution or graphical, as they are the same in this case as well. But there's a specific difference for the elimination method. So the question here will be x plus y equals 3, 2x plus 3y equals 5. So again, we are going to label our equations 1 and 2. But now, when we try to eliminate 1 and 2, these or subtract 1 and 2 from each other, we would not be able to eliminate or get rid of one of the variables, which is what we want to achieve. So what we need to do is make the coefficients the same. So let's say we decide to get rid of x because it's a smaller number, 2 in front of it, so we want to deal with smaller numbers. So what we can do is multiply equation 1 with 2, and that will give us 2x plus 2y equal to 6, as it needs to be done for all terms in the equation. And let's call this 1 star. So now let's write the second one without any change. So 2x plus 3y equals 5. We can see here that by getting rid of 2 from 1 star or 1 star from 2, that would get rid of the x's. But we want to keep y as a positive ideally. So what we're going to do is 2 take away 1 star. As 2 has a larger y, it has 3y instead of 2y. So this would give us 2x minus 2x, which is 0. 3y minus 2y, which is y, equal to 5 take away 6, which is minus 1. So now that we have y equals minus 1, we substitute this into the equation. So we can choose here 1, 2 or 1 star, doesn't make a difference, but let's just do sub y equals minus 1 in 1. So this gives us x plus y equal to 3. We have x minus 1 equal to 3, so x equals 4. Now we need to check this. So we sub y equals minus 1 into 2, and we get 2x plus 3y equals 5. So substituting that in, it gives us 2x plus 3 bracket minus 1 equal to 5. And 3 times minus 1 is minus 3, which is equal to 5 and 2x. So now we add 3 on both sides. So we're left with 2x equals 8 and x equals 4, which is the same as what we had previously. So now we know that the answer, y equals minus 1 and x equals 4, is the correct answer. The key thing to remember here is that we had to multiply one of the equations to make the coefficient equal, so we could easily subtract and get rid of, eliminate one of the variables.
You can download the application on Google Play or App Store, and you can visit our website mathslegends.co.uk.